Welcome, viewer, to part 9 of the TitanBot series. In this episode, we're building two sensor mounts. One sensor mount is for the ultrasonic sensor. This is an HCSR04. And the other sensor mount is for an INA226. This is a current sensor. Let's get started. Begin by creating a new body and a new sketch. We'll put that sketch on the XY plane. Grab the rectangle tool. And we're going to create a rectangle that's symmetric to the origin. And we will begin by setting the width of the rectangle to 48 millimeters. And we'll set the height of the rectangle to 30 millimeters. Next, we'll create two circles. These circles are for the transmitter and receiver on the ultrasonic sensor. Let's make these two circles symmetric with respect to the y-axis, and we'll make it so that both diameters are equal. We'll set the diameter of these circles to 16.4 millimeters, and we're going to set a distance between these two circles to 26 millimeters. These dimensions just come from measuring the sensor itself. And we're going to make it so that the center of these circles is a distance of 10.5 millimeters away from the top of our bracket. Okay, now the next thing that we're going to do is create an aperture for the crystal oscillator on this sensor. That's a slot-shaped can just between the transmitter and receiver. We just need to make this slot so that it's symmetric with respect to the y-axis. And we're going to give it an overall width between arcs of 6.4 millimeters. We'll give it a radius of 2 millimeters. And we're going to set it a distance of 7 millimeters away from the center of one of the circles that we created. So let's put that there. 7 millimeters. And we've got 1 degree of freedom here, so that looks like the setting for the radius was removed, so let's add that back. Radius of 2 millimeters. And this is everything that we need in order to properly mount the ultrasonic sensor, so we can close out of the Sketcher workbench. And we're going to pad this shape out to 3 millimeters. Next, we need to create two mounting pads so that this can be attached to the mobility base for the TitanBot. So I'll click on the surface there, and we're going to reference the bottom of our mount. Grab the rectangle tool, and we'll create two rectangles that are coincident with the bottom. And we're going to make it so that these mounts are symmetric with respect to the y-axis. Now we'll make it so that each mount is 11.5 millimeters in width and 9 millimeters in height. So this shape is fully constrained, so we can close this, and we are going to pad these two features out to 7 millimeters. Now that we've done that, we're going to add the mounting holes to the bottom of these features that we just created. So we'll create two 2.8 millimeter holes at the very bottom. We're going to make them symmetric with respect to the y-axis. And we'll make it so that both diameters are the same, of course. And now we'll set the diameter to 2.8 millimeters. We're going to reference the edge of our mount point here. And let's give it a distance away from the edge of 6 millimeters. And let's make it a distance from the top of 5 millimeters. So there we are. Our mounting holes are fully constrained, so we can close out of the sketcher. And we're going to pocket those holes to a depth of 9 millimeters. See that those cleared all the way through. Next thing that we have to do is create a little bit of a relief around the lip where the crystal oscillator will press up against the bracket. So create a sketch on the top, and we're going to reference the 2 arcs on the slot we created earlier. Now, for some reason, when we create this new arc, even though we begin the arc so that it is coincident with the previous slot's points, we get a redundant constraint message. So what we're going to do is we're just going to move this slot, and we're going to reconstrain them so that they're coincident with each other. So that resolves whatever it is that FreeCAD is getting stuck on. And the next thing that we're going to do is we're going to constrain the radius of the new slot that we created to 2.75 millimeters. And we are done with that. So now we are going to pocket out this relief to 0.6 millimeters. And the last thing that we need to do is we need to create a relief pocket up at the top of this mount. And this is going to allow space for the through hole component for the male pins, signal pins that are attached to the top of the sensor itself. So we're going to reference the top of the bracket, and we'll grab the rectangle tool, create a rectangle coincident with the top. We'll make it so that this rectangle is symmetric with respect to the y-axis. And we're going to give it an overall width of 10 millimeters, and its height with respect to our current vertical will be 3 millimeters. So our shape is fully constrained. We can close out, and we're going to pocket this to a depth of 1.7 millimeters. All right, so that is the mount for our ultrasonic sensor completed. Next, we're going to build the mount for the current sensor. So we'll create a new body and a new sketch that we'll place on the XY plane. And as with before, we're going to create a rectangular shape, but we're going to add a pocket feature in it. So we're going to use the polyline tool. And we're going to create somewhat of a box shape, but we're going to add a pocket to it. And so it's going to look something like this. We'll just offset that. Drag this out. And we'll set this side so that it is vertical. And looks like we've got to add our horizontal constraint there. Okay, so we've constrained our shape. What we're going to do now is we're going to make both sides of this pocket here so that they are equal to each other. And now we're going to set the sizes on these. So we'll constrain the inside of this pocket here to 7 millimeters. And we will constrain the height of this pocket to 5 millimeters. Zoom in here a little bit. We're going to constrain the height of the outer shape to 16 millimeters. And we'll constrain the length of this to 29.5 millimeters. All right, so here is our shape. Now we're going to make this shape so that it is symmetric with respect to the origin. So we'll do that using the constrain symmetry tool. And now we're going to constrain the distance of this pocket from the right hand edge. We'll constrain that to 14 millimeters. And now that we have the basic outline of the shape that we want for this bracket, we're going to create 2 holes. These are going to be what the sensor mounts to. And we'll set the diameter of both circles so that they're equal to each other. We want to make these 2 circles collinear, so we're going to click on the center of both of them and constrain them so that they are horizontal. And now let's set the diameter of one of these circles. So we'll do that to 3.2 millimeters. That allows the 3mm PT screw to just slip through this hole here. Okay, we want to set a distance from center to center of between these holes. Well, actually, let's reference the edge of this pocket here. So we'll set the distance here between that to 4 millimeters. Next, we will constrain the distance from the center of one of these circles to the bottom of our mount. We'll constrain that to 3.6 millimeters. And we'll constrain these circles center to center at 15 millimeters. All right, so that's our shape fully constrained. We can now close out of the Sketcher workbench. And we are going to pad out this shape to 3 millimeters. Let's rotate our view here a little bit. All right. The next thing that we're going to do is we're going to add a cable tie boss to the top of our shape here. So let's left click on the top of this shape and we'll create a new sketch. We're going to reference the right hand edge of our mount. And we're going to use the rectangle tool to create a rectangle that is coincident with the edge. We'll make it so that this rectangle is symmetric with respect to the x-axis. And now we will make sure that we constrain the width of this boss to 3 millimeters. And we're going to constrain its overall vertical height here to 8 millimeters. All right, so that's our boss fully constrained in its outline. We'll close out of this and we will we will pad this to 6 millimeters. Next thing we're going to do is create that hole for the zip tie, and we'll add a new sketch on the edge, and we'll create a circle that's coincident with the y-axis. We're going to reference the two edges of the boss, and then we're going to make it so that this circle is symmetric with respect to those two edges. Lastly, we will set the diameter of our hole to 3.5 millimeters. So now that that's fully constrained, we can close out of that and we can pocket it. And with that, we have completed both of our mounts.